Welcome everyone. So this is our 100th live stream geometry. So big number here. So I want to thank everyone who's contributed to all these sessions, coming on every Sunday, putting forth the time. And I know a lot of you probably put forth more time than I did on this channel. So I appreciate it and want to thank you all. So today I'm going to do some problems from the geometry discussions and problem Discord server. And if we get to it, I chose two other problems, one from the Indian Math Olympiad and one from the Vietnamese. So with that, I will get started. And I see we have one other person joining. So hey, Tomas, thanks for joining. And I will share my screen. Tomas, have you been on here before?
Hello. No, I haven't. It's my first time.
Good to see you. Thanks for joining.
Yeah, thank you too for having me.
Absolutely. So I guess we could start with this problem. I think this one might be a little easier actually. And it's possible we already did it actually. So I'm gonna actually try that. I'm gonna actually start with this one. So this is middle riddle from the geometry discussions and problems Discord servers. So we start with a cyclic quadrilateral. You already did that one. Okay, so yeah, we can skip that one for now and try this one. So we draw the external bisector of VAC. So maybe it might be better. Let's see the best way to draw this. Check the chat. Oh, the India problem is just an angle chase. Okay. So yeah, maybe this one will be a little bit trickier. Okay, so we want to be able to draw the external bisector of VAC. And BAC, sorry. Then in that case, we kind of, yeah, in that case, it's probably is good to draw it something like this. Okay. And I don't want it to look like a trapezoid, but I don't want it to look like, yeah. Let's try something like this. I think that looks good. So you draw the internal and external bisector. There's the internal bisector. Here's the external bisector. And it intersects BC at point X. Maybe I'll do it something like this. So this is point X. And then we draw the external bisector of BBC. Oops. So both the internal bisectors pass through this, and both the external bisectors pass through that. Okay, those are the midpoints of those two arcs. There's the external bisector. L lies on AD such that XL is perpendicular to D. So this is D. We want XL perpendicular to it. And it lies on AD. Okay. Interesting. So this is L. Obviously, XL is parallel to the internal bisector. I don't know if it helps to draw this. And B prime is the reflection of B over AD. Okay. And it almost looks like B prime lies on that, so I'm going to move it just a little bit. Yeah, something like that. And we want to show that BC, L, and B prime are cyclic. Interesting. All right, let's make this look a little better. So we have all these internal and external bisectors. Hide this, hide that, hide that. So let's see. No, I didn't. No, I think E, B, and L. Oh no. What am I doing here? So I think it's so B prime is a reflection of B over AB. So I guess this is kind of like an isosceles triangle. And what was L again? XL is perpendicular to AB. L and L, oh, so that's the last one I have to draw. And once I draw that in, I think that's the full diagram. All right. So we have both, obviously BFAE like has two right angles. All right, so let's see. If this were cyclic, how could we try to show that? So yeah, this right here is a right angle. H is the midpoint of BB prime. So Tomas, where are you from? If you
I'm from Poland.
Poland, very cool.
Yes.
What time is it there?
Can you say that again?
Oh, what time is it there?
It's 3 p.m.
3 p.m. Oh, that's earlier than I thought. All right, very cool. I had someone else from Poland email me recently. All right. So yeah, XG is perpendicular to DE, or parallel to DE, I mean. And we have two right angles. So yeah, this is a right angle, this is a right angle. What would be a good way to show that it's cyclic? Let's see, we could try power of a point. We could try angle using angles. So angle BLD, B prime LD is the same as angle BLD. So I'm thinking maybe we could show B prime LC plus B prime BC is 180. So B prime LC and B prime BC, those angles are both reflections of triangle DBL. So maybe that could help. how would we find angle CLD? DBL plus DCL. Yes, that's a good way to phrase it. Yeah, we want to show DBL plus DCL is 180. I like it. Okay. I wonder, is BLX isosceles? Or is that just a coincidence? I don't think it is. No. All right, looks like Khan is joining us. Hey Khan, thanks for joining. So this is our first problem. So we've simplified the problem a little bit already. We don't really need B prime. Basically, we don't really need, I mean, point E either. But basically, we draw the external bisector from a BDC, and then we drop a perpendicular from X. But yeah, first we got to define X. But yeah, so we don't really need point E. I guess it doesn't hurt to have it. But yeah, this is the problem. So we draw the external bisector BAC, and it intersects BC at X. So here's the external bisector, makes XF. And then we drop a perpendicular from X to the external bisector BDC, and we let it meet AB at L. And then we reflect B over AB, and to get B prime, and we want to show DCL B prime is cyclic. And Stefan showed that that's the same as showing angle DBL plus angle DCL is 180. That's not hard to see because this is a kite right here. I wonder if there's any kind of similar triangles we can find. Is DFLX cyclic? No. So yeah, can we find any similar triangles or cyclic quads here? Or is there any other point on this circle that looks interesting? ALX passes through AE intersect BC. Okay. So I'll draw that. And interesting. So point E is useful then. And is it tangent to AC, or I don't think, or is that, no, it's not tangent. Okay. ALX, it's the Apollonius circle. So every point on it has B as the angle bisector. So let's think about, or how do I say that? Or I is the angle bisector. So LI bisects CLB. Interesting. Maybe that gives similar triangles. I don't know. So now I wonder how much angle chasing we can do, because LAX is LIX, which is this plus this. So yeah, I'm going to write out a little angle chase on my paper here. So DCL is E. All right. We want to show its angle DBL. LBX minus ILB. Is LI perpendicular to AE? Maybe that's obvious. Looks like it. Yeah. Is that Because yeah, this is a right angle. Okay, so LI is like perpendicular. We have like kind of a rectangle here, EGL at this point. And then once we get that, does that make things any easier? I don't know. Obviously, rectangles are cyclic, so. Oh, that passes through this point, it looks like. That's interesting. Is that obvious? It's probably just an angle chase, I would guess. Yeah, I think that's just an angle chase because angle DKL is DKA plus AKL, and that would be AIL plus DCB. AIL is AXL. Yeah, that should just be an angle chase because AXL is 90 minus this angle, which is 90 plus this angle. Sorry, 90 minus this angle, which is this angle minus 90. And then, yeah. Okay. So yeah, we can prove the circle passes through K. It looks like Ki and F are also collinear. So we have a lot of stuff. We have yeah. All right. Okay, so these aren't rectangles, but those are collinear. We have this is cyclic. There would be a lot of cyclic quads here, and I don't know if it's helping at this point, but looks like I don't know if it's from some kind of McKell point that this is cyclic, but it looks true. So with all this information, is this enough to do the angle chase that we wanted? Is AC, okay, that's not tangent. Maybe EK and X are collinear. Yes, I'm just guessing things and I'm guessing pretty well. A lot of A lot of things there. Now I wonder if BEXG is cyclic. No. So BCL. Is this an angle bisector? Let's see. It's very close, but I don't know if it is. No, it's not. One sec, guys, I'll be right back. All right, thanks for waiting. So I don't think LB and E are linear, but let's try one more time. Did I just check this? I might have just checked this 2 seconds ago. Yeah, they're not linear. Okay, so how do we find DBL and DCL? DCL is DCA plus ACL. DBL is DBA plus ABL. So really we want to find a way to relate ACL to ABL. And then once you add twice that other angle, then you want to show that's 180. So what else can we figure out? There's a lot that passes through that point K. Like maybe we could invert about K or something. I don't know what radius, but yeah, just something that I thought of. Anything else that we see about this? Now that we've added some more information. Maybe there's something special about this point. Let's see. Maybe AK, let's see. No. Let's see, what can we do with that circle? Yeah, I'm trying to see if there's another point, special point on that circle. Could it be this point? Don't think so. What if we drew this circle? I don't see anything special about that. So ABL is DAB minus DLB. Maybe that helps. DLB. Yeah, we need something else about L besides that it lies on the Apollonius circle. We need I like that fact. Can we combine it with something else? Is there like a cyclic quadrilateral with L? So if LI is an angle bisector, what does that mean in terms of see, it's like I want to draw LB and then use that. Like I would be the midpoint of this arc, but I don't know how much that does. LAB. Somehow I want to use that this is an angle bisector. Just not sure the right way is. Ooh, that's a big angle chase. So DBL twice angle CLA plus angle CIA. Okay. So CLA plus CIA is 90. Wait. Oh, CLA plus ILA. CLA plus ILA is 90. Is that, let me think about that. Okay, so I'm gonna write it out and then we can edit it. So maybe a lot of these points we didn't actually need. So this.
This angle traces in more lines. It's not just one big quality.
Oh, it's what? It's in how many lines?
Let me see. 6.
Okay. All right.
So maybe better you just write it yourself because I really wrote it very poorly. I can just explain what he did.
Let me hold on. Let me just type it because I think just typing it out might make it easier for me to visualize. But yeah, I might erase it later. But something like this. Okay, so all right, so DBL plus DCL.
Oh, it even copied a bit bad. So the first line is like DBL plus DCL is 180, and then there is a break of line.
Oh, I see. Equals 180. So that's the first line. So basically, that's what you're trying to prove.
Yeah. So the next one is B minus CLD plus 180 minus C minus BLD is 180.
So B, okay, so that's kind of just true algebraically, right?
Yeah, but maybe this actually has a bit of like issues with configuration. So I think in your picture it will be 180 minus B, and the other one will be just C. Since your triangle ABC is tilted to the right.
Okay. So it's like a different configuration that you had. And this one is
Yeah.
just C.
Yeah. That is plus C.
Plus.
And that is equal to 180.
So let's think about that. So angle B, so 180 minus angle B. So this is supposed to be obvious because BLD plus CLD is B plus C. Let me think about this. So this, are you saying this first one is kind of obvious? Oh, you rewrote this up here. Is that kind of what you try to do?
Yeah.
Okay, so it's kind of like an IFF. It's kind of like an if and only if. That's what you're saying, right?
Yeah. Also, yeah, that 180 should be in that line.
Okay, so you're rewriting this. And so DBL is 180 minus angle B. So how do you get so angle B is angle ABC. Is that what angle B is, or is it?
Yeah.
Okay. So
actually DCL should be 180 minus B minus CLD. Yeah.
okay, so like,
So it is, everything is okay, just you will, yeah, it is just like inverted here.
all right, so angle C minus angle BLD is angle DCL. Well, so DCL
No.
would be C minus LCB, right? I'm a little confused.
You just take external angles in triangle and you get it right away. I just skipped a few steps there. So for example, CY-DCL is the first thing in the equation.
Oh, is this DCL?
Yeah, DCL is that. Yeah, it is inverted in the first
Okay.
part.
All right, so it's like this. So DCL is 180 minus B minus angle B minus angle CLD. Because B, because 180 minus B is this, so it's saying this is DCL plus CLD. So DCL plus, okay, so DCL plus CLD is 180 minus this, which is actually I think this is just because DCL plus CLD is 180 minus this, which is angle B. So I feel like this would just be I feel like this would just be angle B minus angle CLD in the because okay, because like so angle DCL is basically, here's what I'm saying. So angle DCL plus angle DLC is 180 minus angle CDL, which is angle B, the way I drew it, right? So this should just be angle B minus angle CLD, right?
Maybe.
Okay. So this is angle B minus angle CLD. And then this one is probably, yeah, it's like inverted. Okay, so DBL is,
Yeah, that one will have 180 minus C. Yeah, actually we have the same picture since I just got confused. Since B is on the right side instead of left in your picture, then we can say that it is like the same.
okay.
In my picture, the triangle is tilted to the left, but B is on the left side, and here it is to the right, but B is on the right side. That means that everything I wrote is just exactly the same.
Okay.
So
So for this,
yeah,
so DBL, what should I write here?
180 minus C minus BLD.
Okay. Interesting. Okay. So 180 minus C is this angle, which is BLD plus, okay, so is that right? Because so 180 minus C is this is angle BAB, right? And DAB, so this is like DAB minus BLD, which would be, this would be ABL, I think. So I think this would be like ABL. And then you'd have to do plus DBA, I feel like. Okay.
I think it is correct.
DBL is this.
Yeah.
Because 180 minus angle C is angle DAB.
But no, angle C is in triangle ABC. So angle C is ACB, yeah.
Okay. Sorry, I got confused. So ACB. Like that.
Yeah.
Okay. That makes sense. Yes. Okay. So, and then you try to calculate this plus this, and then you substitute it in. Okay. So,
We have another equivalence there. So I'm really working everything backwards.
okay. Yeah, I kind of see how you're doing it. Okay. So BLD plus CLD. Let me get rid of all the extra points I added in. So I don't need I, J, K.
Yeah, basically just I is needed there.
Okay. Delete. Did you use this circle?
Yeah, keep it.
Okay.
The Apollonius circle is important.
Okay. So for C, so yeah, I'll say ACB. Yeah, I'll just rewrite these out. ABC. And then this is like ACB minus ABC. And let me just add one more line here. So I'll say this is true because, and then I could do this. can do it like this. It's weird.
No, but we're still doing equivalences. Just at the end, we will get something which is true.
Yeah, basically this. So BLD plus CLD, we want to show it's ABC plus ACB, right?
Minus. So you are ACB
minus.
minus ABC, yeah.
Yes.
And just, you see the first 2 times IXA.
Yeah, so basically I should do it kind of like this. So is it kind of like I should put that in the end? Whoops, didn't mean to do that.
No, just write these lines just as they are, and everything should be fine.
Okay.
Just put the line breaks where I tell you.
Okay.
2 times IXA.
Okay.
And just make 1 line everything before that, before this is true, because before that.
Okay. So everything before this one, just make it like 1 line.
Yeah, we will, that basically says like BLD plus CLD is equal to this difference of angles, which is 2 times IXA. That is what that line says.
Okay.
And just without the last equality of BLA plus CLA, or actually, yeah, actually, let me see. Yeah, that should be in the separate line. 2 BLA plus CLA.
Okay.
And without equality, just like we're taking a new line.
Okay.
Then merge 2 lines before. So like take 2 times IXA and 2 times ILA to be all the 1 line.
Okay.
And the same line as, yeah, and there you put a new line, yeah. And this 2 times IXA, 2 times ILA, you put line before, 1 line before with BLA plus CLA.
Okay. So I can combine those two.
Okay, and I think so. This BLC plus CLA again, you merge that with 1 line before at the bottom, like yeah, and
But wait, this is 2 ILA. Whereas this has only 1 CLA. So should this be like 2 CLA?
everything is all right. Just I just wrote BLA in difference.
Okay. Okay, so
you take BLC plus CLA, that is equal to 2 times angle ILA, which is, okay, just take this 2 times CLA plus ILA and merge it with the thing. Yeah, with that. With that equality with 3 angles.
okay. Just like that. This is BLC equal ILA. So this is weird. This is confusing me.
Okay, just wait a bit.
Okay.
And just take delete the equality symbol of the last line, and that should be it.
Okay. Just
So
delete.
not the whole line, just that equality, and that should be then all right.
Wait.
And just put equality sign in the middle before 2 times CLA plus ILA.
Like that. Or
Okay, that equality sign is okay, just at the start of line.
this one?
Yeah.
Okay.
Okay, I know this is all confusing, but I will explain it.
Okay.
So the first line is okay. That one with ABC minus CLD plus 180 minus ACV minus BLD. That is explained, and that is just like using the fact that sum of angles in a triangle is 180.
So wait, so let's
And-
think about that. BLD plus CLD.
Yeah.
Is this obvious, or wait, if we prove this, that would solve it, right?
Yeah, this is just all equivalences. We start from DCL plus DBL is 180, and then take equivalences until we get something which is true.
Okay.
You see
So
in the last line.
let me add the equivalences just to make it so if and only if BLA, if and only if.
Also, just delete this line of text. This is true because it is
Yeah.
just. Yeah. Okay. So.
All right.
You see from that line, the second line from all of those, you can cancel 180 and bring BLD and CLD to the right hand side of the equation, and you will then just flip it, like take it to the left side.
Yeah.
So you will be left with now I'm wondering if this should be like reversed.
BLD plus CLD is, oh, it's like the net, it makes it look like it's the negative of it.
Yeah.
I think ABC, I think it should be ABC minus ACB.
Yeah, probably.
ACB.
Yeah. And that should be equal to 2 times the angle IXA. So this should be explained. If you take the tangent to the circle ABC at A, then it would pass through the center of that Apollonius circle. That is a well-known fact.
Yes.
And you could also very easily see that angle in this case, since J is that intersection point, angle AJI is equal to angle B minus angle C in this triangle ABC.
Okay. Angle A, because angle AJI is the same as angle IAJ. I'm guessing that's kind of how you're doing it, right?
No, that's not true.
Oh, you're just
Yeah.
saying this minus this, which is, and because it's tangent. Well, this is 180 minus B. Like angle JAC is 180 minus B. So
No, it is equal to B. Actually, yeah, CAJ is 180 minus B, so you can get AJC easily.
Okay, so it's 180 minus. Okay, so
And since J is the center of this circle, you just take, you'll just see that it is 2 times the AXI, since we have the center and the angle at the circle.
okay, so 2 times IXA is AJI. So angle IJA. So I'll add that in. So ABC. So this angle plus this angle is this angle. Is 180 minus B. Yeah, okay, I'll just, yeah, I think it's not too hard to do this. I'll just leave it like that. So this IJA was just 2 IXA. And then BLA plus CLA. BLA plus CLA.
This part is completely trivial. You just have that BLA is BLD.
Yeah, this is trivial, but each of those are equal to that. And then
IXA is ILA, so.
okay. And then BLA is BLC plus CLA, that's obvious, plus CLA. Okay, and then this ILA is CLA plus I. Okay, so this equals this, but for this side, okay, so
let me just see. It should be ILC instead of ILA.
on this
There. That is okay, but the line below it.
yes.
Yeah. ILC, and also on the line below it again.
Okay.
So BLA is just equal to BLC plus CLA, and we have another CLA. And then you take ILA, 2 times ILA. ILA is just equal to ILC plus CLA. So that is also
okay.
Easy to see.
Okay.
And in the end, you just take a BLC as twice CLI, since we have a Apollonius circle.
Apollonius circle. Okay. So
and that finishes it.
Okay. So IALX is okay. So yeah, I'm just gonna write it up here. IALX is the Apollonius circle. Okay. Let IALX be the A Apollonius circle. Is the A Apollonius circle of triangle ABC. And then since ILX is 90, and L lies on that circle. And that means that LI bisects BLC. And we have this. So once we have that, So this, so I'll say this last line, which is obvious. And then this means that angle DCL plus angle DB prime L equals 180. And that means that BCLB prime is cyclic. All right. Okay, nice. So yeah, that Apollonius circle was the key. After that, it was kind of yeah, a long angle chase. But once you see that Apollonius circle, that's really the key. Very cool. All right, so I will move on to the next one. This one looks kind of interesting. So we have a triangle. K is the foot of the symmedian. So I guess my favorite way of doing it is just draw the tangents at B and C, and we could let that segment intersect. All right. So we have this and this, and this is K. So that's the symmedian. Might as well draw this because it'll give us the harmonic quad. Oh, but I'm going to rename it. So just call it X. AP is the diameter. Okay. So we can call this O and reflect A over O. That is AP. And AP intersects BC at E. And V lies on AK, so that BV is perpendicular to AP. Interesting. Okay, so this is V. I'll just draw this point too. That's V. And we want to show E lies on the radical axis of BVP and AVC. So it has the same power with respect to those two circles. All right. And yeah, I guess I don't need point D, but it doesn't hurt. Just takes up space on the screen. All right. So if I move A up higher, maybe something like that looks good. But now it's E, looks like it's like, yeah, something like that. But now G and O are like the same point, which I didn't see. Oh well, something's gonna give. That looks good. Yeah, if I make A more in this direction, then it looks better. So E and K are the feet of the diameter and this median. Yeah, I guess K is kind of irrelevant, actually. I wonder if you don't. Okay, I was wondering if that was the midpoint of.
Intersect BV with AC.
Okay.
We can completely get rid of D and K.
Yeah. Okay. So.
It is very easy to prove that V is midpoint of BH.
V is the midpoint of BH.
Yeah.
Okay, so then we don't need. We can hide all this other stuff for now. So we draw the perpendicular from B to AO, and V is the midpoint.
Also, ABH is just angle C.
ABH, or sorry,
Yeah.
ABH,
ABH is angle C that is
easy angle.
yeah, obvious by this perpendicularity.
Yeah, because this is 90 minus this. And C, angle C. Is angle APB, so yeah. This is 90 minus this, which is 90 minus APB, which is 90 minus ACB. Yeah, do I need point F? I'm going to delete point F. Well, it could be useful because V is the midpoint of BH, so FB would be parallel, but. So let's see. So V lies on the symmedian. So yeah, I'm just trying to think why V is the midpoint of BH. So basically, we want to show that AV is a symmedian, but basically, is it that ABH is like inversely similar? Because ABH is inversely similar to ABC. So let's see. So yeah, the midpoint of BH is, yeah, because they're inversely similar, is going to lie on the symmedian. That makes sense. Sec, I'll be right back. All right. I'm back. Let's look at the centers of these circles. See if there's anything special. I wonder if the problem, because we can try to use Casey's theorem. So we want to show that E has the same power with respect to these two circles. But if we take the difference between the power of E with respect to this circle and ABC, that would be 2OF times the distance from E to BP. And similarly, it would be 2OI times the distance from E to AC. And the ratios of those two distances should just be AC over BP. So I think the problem is equivalent to showing that OF over OI is BP over AC. Or maybe the ratio is the other way around. I don't know if that makes it easier or not. Yeah, I could check that if I want. So OF 3.14. 3.14 over 2.4. What's that? Use my calculator. 3.14 over 2.4. That's about 1.31. And then, whoops. .6 over 5.06 is 1.31. So yeah, that's another equivalent way to show E lies on the radical axis. Yeah, I don't know how you'd find OF and OI. That's the thing. Oops. Maybe E is like the midpoint of this. No. Wait a sec. Yeah, I don't think these concur. look at this circle, or because then BV would be the radical axis. So and that's kind of another way we could think about it. Then, okay, so can we calculate FJ? Let's see. I don't think these concur, but let's see. Yeah. So actually, I just realized the problem. Well, actually, never mind. I thought the problem was symmetric for a second if I try to do it the way I was thinking. But yeah, if we could show OF over OI is AC over BP, then that solves it. And that might be kind of bashable. Because OF, OB, FP is a kite. Let's think. I'm going to try using up signs. F. P, P. And then C over OC. And if you divide the two, so OFP is equal to OFP is 180 minus BVP. Sine BVP OF. Doing some math in my head. P, so OFP. So that would be sine of BVP over sine of OIC sine ABC. Okay. So I have something that if I can show this, that would solve it. So I'm going to write it out. Sorry, sine OPF over sine OCI is equal to AC over BP sine of BVP over sine of ABC. If I can show this, that would solve it. Which is kind of interesting. So OPF is APB plus BPF. Let's see. Which is BVP minus 90. See what time it is. It's a little past 10:30. So OI passes through the midpoint of AC. And is this cyclic? Yes. So I don't know if that helps, but this is cyclic right here. And actually, does this pass through I? It does, right? Actually, I'm not sure. No. Okay. One sec. Okay. Yeah, we can move on to the Vietnamese problem. Whoops. So, Khan, I'm not sure if you already saw this problem. Or when this contest happened, but it looks interesting. So E and F are on BA and CA, so that BF equals CE. So that's kind of a somewhat familiar configuration. So
we've done this on a previous session.
oh really? We already did this?
Yeah.
Okay. Was there a more recent Vietnamese contest?
Oh yeah, and we haven't done the second day problem.
Okay. So there was
It's problem 7. Yeah, that's another one.
did we do any of the other problems? Let's see. So if I do check this out, contests. So was it in, is it this one or a different one? Oh, is it this one right here?
Yeah. It's the day 2 P3.
That looks so hard. Do you want to do it or does it look too hard?
Let's do it.
Okay.
Yeah, I think you guys can do it.
All right.
It's doable.
It's doable. Okay. All right.
And this contest was last year, so there's an upcoming VMO 2023 in next month. This time next month.
All right. So yeah, it should be fun doing that. All right, so we have a triangle ABC.